Okay, we have here another problem. This is an example of a continuous beam. We are going to solve or determine the reaction of each support using three-moment equation. EI is constant. So, first we have to break the beam because three-moment equation, this is the analysis of the relationship between the moments between any 3 points in the beam. So we have to break this one. Okay, we have this. Okay, for our span 1. This is our span 1. So you have here the reaction A. This is our span 1. And this will be our reaction B. So we have here, we assume that that is the direction of our moment at B. And the load is 36 kilonewton per meter. Okay, so for our span 2, okay, we have also this one. Okay, this is for your reaction B. This is our span 2. And this is for your reaction at C. We have to convert this into a moment form. The overhang load, the overhang uniform load of 36 kilonewton per meter, and the concentrated load, which is 6 kilonewton. So we have also this one as our moment at B. Okay, so here for our C, we have moment at C, we have to compute the moment. Okay, for our span 1, the length is 8 meters. And for our span 2, you have 6 meters. So next, we will determine the moment at C. Okay, so this is the loading, the overhang loading. So you have here 6 kilonewton and you have 36 kilonewton per meter. Okay, this is the direction of moment at C. You have here the reaction at C, and the span is 2 meters. So for the moment at C, that is equal to negative 6 times 2 minus 36 times 2 times 1. And that is equal to negative 2 times 2 minus 36 times 2 times 1 is equal to 84 kilonewton meter. Okay, so we have now our moment at C. For moment at A, that is equal to 0. Since your support A is pin, so you have 0 moment. Okay, so we need also to determine the 6A1 bar A1 over L1 for our span 1 and span 2, because the formula, okay, for the 3-moment equation, you have this formula MA L1 plus 2 MB L1 plus L2 plus MC L3, no, L2, sorry, L2, that is span 2, plus 6 A1 bar A1 over L1. Okay, plus 6A2 bar B2 over L2 is equal to 6EI times H1 over L1 plus H2 over L2. So this is the formula for the three moment equation. So we already have the moment at C, we also have the moment at A, but we need to determine this value, the 6A1 bar A1 over L1 and 6A2 bar B2 over L2. We can determine that value using the table, no? So I have here the table taken from the table of Ferdinand Singer for the strength of materials. So you can find any value for this. Okay, so you have to compare the value and the loading, no? Loading in the table to the loading of your beam. Okay, so since our loading there is a uniform load, so we will check for the uniform load for the value of 6A1 bar A1 over L1. So we have here for our loading, so we have this value, okay, and also for this value. Okay, that is W L cube over 4. So, which is also equal to the big W L squared over 4. So, the small W, that is the kilonewton per meter. That is the load per meter length. While the big W, that is the resultant. That is the load, that is in kilonewton. So, we have to okay, so we have to compute our value. So we have where your 6A1 bar A1 L1 for the span 1. So you have here W L, okay, W L cube over 4. Okay, that is W L cube over 4. Okay, so we have, okay, you have 36. The load is 36 for span 1. Okay, you have 36. Then the length is 8. So you have 8 cube over 4. So this is equal to, so 36 times 8 cube divided by 4. So you have 4608. Okay, so you have 4608. Okay, that is kilonewton meter squared. Okay, then for our, okay, I have to move. Okay, so for the 6A2 bar B2 for the span 2, so you have 6A2 bar B2 over L2. So that is also equal to WL, okay, WL cube over 4 over 4. So you have, for the span 2, you have 36, okay, you have 36 kilonewton per meter. So that is the load. So you also have 36. Then the span, that is equal to 6. Okay, 6 meters. So you have 6 cubed over 4. So you have 36 times 6 cubed divided by 4. So you have 1944. 1944 kilonewton meter squared. So this is now our value. Then, since if we will draw the elastic curve of this beam, okay, it's look like that. So the h1, the vertical distances at point B, h1 and h2 are equal to 0. So these are equal to 0, and also that is also equal to 0. So what we have now for our equation is only, okay, moment at A, L1 plus 2, moment at B, L1 plus L2, okay, plus MC L2, okay, plus 6 A1 bar A1 over L1 plus 6 A2 bar B2 L2, which is equal to 0. So since our M moment at A is also equal to 0, so what we only have 2 moment at B times the span 1, you have 8, and span 2, you have 6. So you have 8 plus 6 plus, for the moment at C, you have negative 84. Okay, negative 84 times span 2, you have 6. Okay, plus 4608. 4608. So I have to copy this again, make it smaller. Okay, so also have plus 1944. So that is equal to 0. So we have now our moment at B. So that is equal to, okay, 84 times 6 minus 4608 minus 1944 all over divided by 2 times 8 plus, okay, 8 times 2 plus 6. So moment at B will be equal to, okay, we have to calculate. So we have 84 times 6 minus 4608 minus 1944, okay, divided by 2 times 8 plus 6. So the answer is 216. Okay, that is negative 216 kilonewton meter. Okay, so that is our moment at B. But since in the problem we need to determine the reaction of each support, so this is an example of an indeterminate beam. Okay, for the reactions, I have to copy this beam for our span 1, and I have to place it here. Okay, so this is for our reactions. Since our moment at B is negative, so the assumed direction of the moment at B is not the correct one. So we have to change the the direction of our moment at B, so this will be equal to 216 kilonewton meter. Okay, so for our reaction at A, that is left, no, the left summation moment left of B. So we have to take summation moment B. So this is equal to 0. So this is the summation of moment left of B. So you have here 8 RA, okay, minus 36 times 8 times 4, okay, then plus 216 equal to 0. So our RA is equal to 36 times 8 times 4 minus 216. So that is all over divided by 8. So you have, okay, so the answer is 117 kilonewton. Okay, this is for the moment, summation of moment left of B. For the right of B, we have to take this. I have to copy also this one. Okay, this is the one. I will copy this one. Okay. This is for the moment left of B. But I have to consider the whole part, the whole beam of left of B. So I have here, okay, so this is the whole load of the beam. So you have here 6 kilonewton and the span is 2 meters. So since our moment at B is at the clockwise direction for the left of support B, so here our direction also we have to change the direction of our moment at B. So this is equal to 216 kilonewton meter. Okay, so that is the opposite. Okay, now we have to take summation moment at B equal to 0 to get the reaction of C. So you have 6 RC, okay, plus 216 minus 36 times 8, then we have 4 minus 6 times 8 equal to 0. So your reaction of C, you have 36 times 8 times 4 plus 6 times 8 minus 216 all over divided by 6. So you have 36 times 8 times 4 plus 6 times 8 minus 216, okay, divided by 6. So the answer is 164 kilonewton. So this is your reaction of support C. Now we have to determine the reaction of the support B. So again, I have to copy the whole beam. Okay, so we have this one as our 6 meters, and I have to copy the reaction A, that is 117 kilonewton. Then you have for C, you have 164 kilonewton. Okay, so we have to determine the reaction of B. So, you can take summation moment any either at support A or at support C. So, here, if I will take summation moment at support A, so which is equal to 0. So, you have 8RB, okay, plus 6 plus 8, that is 14 times RC, okay, minus 36 times, okay, 36 times 16, okay, times 16 times 8, okay, minus 6 times 16 equal to 0. So, RB now is equal to 36 times 16 times 8 plus 6 times 16 minus 14 times 164 all over divided by 8. So, our reaction for B, okay, plus 16 times 6 times 14 times 164, okay, divided by 8. So, that is equal to 301 kilo Newton. So, this is, okay, these are our reactions. Okay, to check if all our reactions are correct, so we have to take summation forces vertical equal to 0. So you have RA plus RB plus RC equal to 36 times 16, okay, plus 6. RA is 117, RB is 301, RC is 164. So, it should be 36 times 16 plus 6. So, that is 582. So, 117 plus 301 plus 164 equals 582. So, both sides are equal. So, this is correct. So, now, we can conclude that the reactions are correct. So, I hope you understand this example. Okay, thank you.